Everybody, welcome to my channel, and today we are going to do chemical bonding. So, a chemical bond is defined as a force of attraction between any two atoms in a molecule to maintain stability. Okay, so this much is pretty much clear. So, what is a chemical bond? So, the chemical bond is defined as a force of attraction between two atoms in an molecules to maintain stability. So, basically, when two atoms come together to form a molecule that is known as chemical bond. And why do they form a molecule? To attain stability and to get fixed amount of fixed amount of electron in their valency shell. So we will understand it later how many shells are required and all. So we will start from noble gas. So noble gas have stable electrons configuration, i.e. the outermost shell is completed. So the number of electrons they require to complete their outermost shell, it is completed, and they do not require stability. They have 2 electrons in their outermost shell or 8 electrons in their outermost shell. Okay, so 2 and 8 electrons are required for both scenario to be completely stable because of a law which is I am going to be mentioning down below. Okay, so the next is they do not lose, gain, or share electron and are inert or unreactive. So basically, they do not lose or gain or share because because why the chemical bond is formed? Because they want to attain stability, but in this case they are already stable, so they require like no electrons, so they do not need to require to react. So that's why they are also not reactive, and when there is no reaction, there is no share, loss, or gain of electron. So another one is the next we will come up with atoms of element other than noble gas. Okay, atoms of element other than noble gas, okay, have unstable electronic configuration, i.e. their outermost shell is incomplete. For example, sodium and all, they have their outermost shell incomplete, whereas like helium has complete, it's a noble gas and it has its outermost shell completed with 2 electrons, but these do not have. They can lose, gain, or share electrons and are chemically reactive because they what we can say, because their outermost shell is incomplete and they want to achieve stability, so they would react, and due to which they would be share, gain, or loss of electrons in this. Reason for chemical bonding. Okay, so the driving force for atom to combine is related to the tendency of each atom to attain stability electronic configuration to the nearest inert noble gas. Okay, so for an atom to achieve stable configuration, it must have 2 electrons in its outermost shell, nearest noble gas helium, duplet rules, and 8 electrons, which is octet rule. So basically, due to this rule, at least an atom should have 2 electrons in their outermost shell or 8, so to make it stable. Okay, so the next one is method for achieving chemical bonding. So there are 3 types of bond which could be created, which is electrovalent bond, covalent bond, and coordinate bond. Okay, so what is electrovalent bond? It is also known as ionic bond. The chemical bond formed between two atoms by transfer of one electron to another from the atom of metallic electropositive element to an non-metallic electromagnetic element. So what happens in this case? When a metal reacts with non-metals and there is gain or share of electron, and those kind of bonds are known as ionic bond. So other is ionic compound. The chemical compound formed as a result of transfer of one or more electrons from the atom of the metallic electropositive element to an atom of electrometallic electro non-electronegative element. Okay, so what is this? So this is the compound when a metal or non-metal element reacts with each other, and there is a loss, gain, share of electrons, due to which the product is released, that is known as ionic compound. So what is electrovalency? The number of electrons donated or accepted by the valency shell of an atom of an element so as to achieve stable electronic configuration is called electrovalency. So basically, uh, for example, let's say oxygen. Oxygen has 8 electrons, and no, it's what we say, the valency. So the its atomic number is 8. So its valency is 2 and 6, and it requires 2 electrons to achieve 2 electrons to achieve stability. So in reaction it will get 2 electrons, so its valency would be -2. So that I will show you on a piece of paper as how this electrovalency and all works, due to which we can create some bonds, and which is also helpful in uh, it also helps in creating the chemical bonds and various things. So we have now the next one is condition for the formation of an ionic bond. Okay, ion ionization ion ionization potential IP, lower the value of IP of a metallic atom, greater the ease of formation of the cation. Okay, so if the ionization potential is lower of a metallic atom, it would have greater ease for the formation of cation. Okay, and then is electron affinity. Higher the value of electron affinity of a non-metallic atom, greater the ease of formation of ions. So if the atomic affinity is higher, then it is easier for non-metal to form ion. So what is electronegativity? Larger the difference in electronegativity between the combination atom, greater the ease of electron transfer. So greater the electronegativity, there would be greater the transfer of electrons. Okay, so the next one is formation of electrovalent compounds, formation of sodium chloride. So this one is a pretty basic example of ionic equation. So let's start with, so Na plus an electron, sorry, minus an electrons give Na plus. So in its outermost orbit it has 281. So now when they in a reaction, when there is a loss, or when there is a loss of electron, it would get plus. So it will become, as there is loss of 1 electron, it would be +1, and it achieved the stability as its outermost shell has 8 electrons. And then again with when chloride sorry, and again with chlorine, it has, so it receive 1 electron from sodium, so it uh, it will have -1. So the and its outermost get complete by 8 electrons, so it is also stable, resulting it to be result in formation of NaCl. So now the electronic dot structure diagram. Okay, so NaCl, so we will, we can say, we have to make the number of outermost shell has. So sodium has 1 in outermost shell, so 1 dot. And for non-metal, we will use different sign instead of the dot we use, so it would be much easy. So plus the, and it has 7 electrons in outermost shells, so 7 different X we have made on it. So that gives us Na plus then Cl with 8 electrons, which is equal to NaCl. So that is our dot structure. So the next bond is covalent bond. Covalent bond, the chemical bond formed due to mutual sharing of electron of covalent bond, the chemical bond formed due to mutual sharing of electrons between the given pair of an atom of non-metallic element. Okay, so when there is a mutual sharing, where two atoms use 1 electrons, that is sharing. So I will also show you this example on piece of paper. So then covalent compound, the chemical compound formed due to mutual sharing of electrons between the given pair of atom, therefore forming a covalent bond between them. So that's much more clear. Then there again is covalency, the number of electron pair with one atom shared with one or more atoms of the same kind or different kind to achieve stable electronic configuration is called covalency. Then our next one is non-polar covalent compound. Covalent compound are said to be non-polar when they share pair of electrons and are equally distributed between the two, like example H2Cl2, O2NO2, CH4 CCl4. So then is polar covalent compound, where they use the compound which are said to be polar, where they share a pair of electron to unequally distributed between two atoms, like H2O, NH3 or HCl. Okay, so then there's a condition for formation of covalent compound: ionization potential, electronic affinity, then for electronegativity. Higher the difference, different both the atoms, then electronegativity difference should be negligible between two combining atoms. So atoms like carbon and hydrogen, the configuration of carbon is 2 4. So nearest noble gas neon, carbon needs 4 electrons to complete their octet. Okay, and then hydrogen plus 1, nearest 2, helium. So hydrogen needs only 1 electron to complete its duplet. Then one atom of carbon share 4 electronic pair, one with each of the 4 hydrogen atom of hydrogen. So you see, this forms CH4. Then next is coordinate bond. Okay, so this one is very important bond. The bond formed between two atoms by sharing a pair of electron provided entirely by one of the combining atom but shared by both is called as coordinate bond or dative bond. Example: ammonia ion NH4, hydrogen ion H2O. So what is coordinate bond? Okay, so in this both atoms share an electron, but those electrons are only used by one atom. So then lone pair of electron, a pair of electron which is not shared with any other atom, is known as lone pair. It provides to the other atoms for the formation of coordinate bond. So which those bonds are called lone pair. And then a condition for formation of coordinate bond: one of the atoms must have at least one lone pair of electron, example ammonia, water, and then another atom should be short for least one lone pair electron, example hydrogen ion. So this is the formation of H3O, where there is one lone pair and it could accept one hydrogen. So as you can see, this is the example of this coordinate bond, and you can see one lone pair being used which is being used by an arrow. Just let me just highlight this. Wait. So you can see it is black. So as you can see, there is an arrow like OH, which indicates a lone pair. Okay, so the next one is H2O plus H is equal to gives H3O, hydrogen ion. So in water, the O atom contains two lone pair of electron completing the octave. The hydrogen ion accepts one lone pair of electrons of the oxygen of water molecules, leading to the formation of coordinate bond. So the property and comparison of electrovalent and covalent bond are: these are hard. So electrovalent are hard solid, okay, consisting of ions. These are gaseous, liquid, and soft solids. Okay, so they are formed from these are non-volatile with high boiling point and high melting temperature. These are volatile with low boiling and low melting point. So the electromagnets are good conductor of they are good conductor of electricity in fused state. They are non-conductors of electricity in solid, molten, or aqueous state. So these are the soluble. They are soluble in water but insoluble in organic solvent. These are insoluble in water but dissolve in organic solvent. They show rapid speed of chemical reduction in aqueous solution. They show slow speed of chemical reaction in aqueous solution. So the next one is last one is redox reaction. So in which oxidization, when an atom or ion loses an electron or electrons, oxidization takes place. Reduction, when an atoms of ion gains electron or electron, reduction takes place. So oxidizing agent, the atom or ions which gains an electrons or electron in an oxidizing agent. Then reducing agent, the atom or ion which loses an electron or electrons is a reducing agent. Then redox reaction, a chemical reaction which takes in which the loss and the gain of electron take place simultaneously, is called redox. Example of it is CuO plus H2, in which H H2 gets one oxygen which becomes H2O, and from where H2 is this is getting oxidized. So CuO is oxidizing agent, and Cu, as the oxygen is removed, so it become reduced, and H2 is reducing agent. So when it reacts, it gets oxidized, and it forms a chemical reaction as CuO plus H2 gives Cu plus H2O. So that's it for today's video. Please like, share and subscribe, and if you need any improvement or any queries, you can please write it down in the comment section. Thank you.